Hello everyone. Today we are talking about systems of equations. So systems of equations are when you have two equations where you're trying to figure out what the values represented, the missing values represent. So we have three methods we can use when doing this. First off, we can use graphing. The problem though with graphing is that our equations always need to be in y equals mx plus b form. Otherwise, we don't understand how to graph it because we need to use our y-intercept and our slope to figure out where they intersect, which will be our solution for the two systems of equations. Method 2 is substitution. If you can figure out one of them equals y equals an equation, you can take that and plug it into the second one, solve for a variable, and then work backwards to figure out the other variable. Method 3, elimination. Elimination is the easiest, but at the same time, you can only use it in certain circumstances. So here, let's take a look at some examples of these. So my first problem right here, I have my two equations, y equals x plus 1 and 2x plus 3y equals 18. So as you can see, what I've done actually, first off, we had to figure out which method we want to choose. So let's go back real quick and look. So we have graphing, substitution, and elimination. Now graphing, like I said, equals y equals mx plus b. One of them is in that, but at the same time, that's probably our last resort to use. Because this one right here, we'd have to completely redo to figure out y equals mx plus b. So I'd recommend probably substitution or elimination. Elimination, though, we don't really have anything that will cancel out or eliminate, so we can't use that either. So let's look at substitution. So substitution actually is perfect for this because one of our equations already is solved for us. Y equals this. So by knowing what y equals, we can take it and plug it in for this y. See how I wrote this green arrow right here? We literally plug it in. So as you can see right here below it, all I did was say the same exact one right here, except instead of y, we have x plus 1. Remember, we need to distribute, so we do 3 times x, 3 times 1. And I rewrote it right here. We combine like terms, which the 2 and the 3 here become 5. We can move this 3 to this side. 5x equals 15, divided by 5, x equals 3. So now I know what one of my variables equals, but I need to figure out what the y is. So the red line right here, plug it back into our original. So y equals 3 plus 1, so y equals 4. So our solution would be 3, 4, because x, remember, equals 3, y equals 4. So that's substitution right there. Well, let's take a look now at elimination, okay? Now, the difference when you have elimination is you need to have something that cancels out. So you're going to add the two equations together. I know it sounds crazy. So right here we have 2x plus 4y equals 6, negative 2x minus 7y equals negative 9. If you notice right here, for elimination, you always want the same coefficient. So you look for 2 and 2. See right here, 4 and y, and 4 and 7, that doesn't match up. So the 2's match up, and it's already perfect because 1's negative. So which means when we add them together, we have a positive 2 and a negative 2, so they cancel out. So which is perfect why I put a little x over that. So we add the rest of them, so 4 plus negative 7 equals negative 3y. 6 minus 9 equals negative 3. So since we just divide by negative 3, y has to equal 1. Once we know what 1 equals, same thing, just plug it back in for y up here. So down here you can see I just plugged in 1 for y. By solving all the way here, we get to just simply x equals 1, which is very easy for us because our solution is just 1, 1. So let's now take a look at one more. So you think this last one will be graphing, but graphing, remember I told you, is kind of a last resort because only if they're both in y equals mx plus b can we use it. So I want to actually take another look at elimination, but this time it's slightly different. So this is our equation right here, okay? Take a look at it for a second. See if you notice what's wrong so we cannot eliminate it right now. Did you figure it out? Oh, look right here. These right here are both positive. So right now, technically, when we add these together, if we add this all together, we want something that's going to eliminate, right? It means cancel out. If we add these together, they're not going to cancel out. They would just add together to become 4y, which is not what we want. So let me erase these real quick. What can we do to make one of these negative? I like your style. We'll change this entire thing by negative 1, which means that this becomes a negative, this now becomes a negative, And this now becomes a positive. So we basically changed all the signs on one of our equations. So now when we add them together, they actually cancel out to become 0. So now we have 8 minus 4x because we changed the sign. So now we have 4x equals 6 plus 9, which gets us 15. Uh-oh, looks like we're going to have a decimal here. So then we have x equals 15 over 4. So then once we know what x is, we take x and we plug it back in up here. I'm going to have to get a better angle actually. So then we have right here, because all I did was take this and plug it back in. So now we have to do 8 times 15 and then divide it by 4. Whew. So we know that 30 times 4 would be 120. 120 divided by 4, which would be, what, 30? So 30 plus 2y equals 6. So all I did right here was simplify that. So now we had to figure out just what y would be. So we can subtract 30, and we need to say that 2y equals, what's that, negative 24. So then y would end up becoming negative 12. So our solution would be 15 over 4, comma, negative 12, which we could also write this actually as 3.75, comma, negative 12. Sorry, I started to go lopsided. I'm kind of at an angle here. So that will be our solution right there. So remember, elimination, the key here is you have to make sure that you have something to eliminate. If you don't have something to eliminate, all you're doing is adding together and making one bigger equation which we can't solve. By eliminating, we can get one variable, solve for one variable, and use it to find the other variable. Alright, hope you enjoyed.